All right, so coordinate geometry. So there are two main subtopics under coordinate geometry. There's straight lines, and then it has the circle, but we're doing straight lines first, and then we'll do circles. Right. So syllabus objectives, we have to determine the equation of a straight line, determine whether the lines are parallel or perpendicular by looking at the gradients, and then the last one, point of intersection of two straight lines. But for today, we're just doing the equation of a straight line. All right. So the gradient or slope is a measure of how steep a line is. So by looking at the gradient, I could tell you which line is steeper than which, and if a line has a gentle slope, right? Right. The formula to find the gradient, because they can ask you to find the gradient in a question, we'll learn how to do that just now. It's in the slides, right? So gradient is denoted by m. So sometimes you'll see gradient, sometimes you might just see m. The formula for that is y2 minus y1 over x2 minus x1. Or you would also see vertical distance. So this is the vertical distance, or the change in my y values, divided by the horizontal distance, and that's also known as the change in my x values. So for anybody who doesn't know, who didn't do this topic yet, coordinates look like this. They're in the form x, y. My x coordinate, well, my x value. What I would do, I would look at this horizontal line. This horizontal line is called the x-axis. Sorry, that's not a straight line, but this is the x-axis. And if I wanted to identify my x value, say this is my point A. I draw a line like this. So we know that my x value in this case is -8. You don't need to worry about this. It's another topic. I just need you to understand the basics right now. But we'll go through this more in depth in another topic, right? So that's how you find the x value. The y value for that same point, this is my y-axis. This vertical line here, called my y-axis. And we'll draw a horizontal line from my point A to get my value for y. In this case, it's -2. So the coordinate for that point A, just in this case, would be -8, -2. I just need you to understand this. So everybody understands? We'll do this more in depth in another subject, but another topic. But I just need you to understand the basics right now. So everybody understands this? How to find the x value and the y value for coordinates? Yes, no.
Yeah.
Yeah. Can I have one more person tell me yes or no?
Yes, miss.
All right. Thank you. Right. So when you're looking at questions, this is usually how the question might come. They might tell you to find the gradient joining points 1, 1, and 5, 7. This is just an example. They might give you 2 points. So in this case, the point is 1, 1. So my x value is 1, my y value is 1. And then for the next point, my x value is 5, my y value is 7. Like I said, I'll show you how to do that in another topic later down. Okay. So remember from the slide just now, the gradient, also known as m, is y2 minus y1 over x2 minus x1. So the first thing I want to do when they ask me a question like this, I want to identify my x and my y values. Remember, a coordinate or point is in the form x, y. So I have this in the form x, y, and I have the point 1, 1. So that means x1 is 1, y1 is also 1 in this case. And in the case of 5, 7, x is 5 and y is 7. Everybody understands that, how to identify x and y? Yes, no? If not, I'll explain it again. You understand that? Yes or no? Maybe one more time. Okay, I said yes, miss. You're the person. What were you saying? Let me just move on. Right. So, step 2 is to use the formula. Formula for gradient. y2 minus y1 divided by x2 minus x1. Up here, we said that y2 is equal to 7, and that's why I put 7 in. Then I said y1 is 1. That's why we have 7 minus 1 at the top, because that's y2 minus y1. At the bottom, x2, we said x2 is 5, minus x1, we said x1 is 1. So that's why I have 5 minus 1. So 7 minus 1 is 6, 5 minus 1 is 4, but that could be reduced to 3 on 2. Everybody understands that? So if they had asked you to find the gradient, that's the answer, 3 on 2. And that's it. That's all it is to it. Everybody understands that? I have more examples, so if you don't, you might guess it on the next example. Don't worry. Everybody understands this? If not, it's okay, just let me know.
Yes, Miss, I understand.
Okay, so another example, they want us to find the gradient again. But in this case, our points are 1, 5. So x is 1 and y is 5 and 3 minus 2. 3 minus 2. So in this case, in this example here, I chose to name this coordinate x1 and y1, and I chose to name this one x2 and y2. But you see in this case, I chose to name this one x1 and y1 and this one x2 and y2. But it doesn't matter, it's interchangeable, whatever you want to do. So let me just go through this one. So I said 3 minus 2 is my x1 and my y1. So x1 is 3, because remember the form for any coordinate is x, the x value, then the y value. So that's why I said x1 is 3 and y1 is minus 2. And in this case, x2 is 1 and y2 is 5. The formula for gradient, m, remember it could be denoted by m, is y2 minus y1 over x2 minus x1. We said that y2 is 5 minus, this is a trick that they usually do. So we said y2 is 5, looking up here, y2 is 5 minus, because of the formula, but y1 is a negative number. So what we do, we put that in brackets. Over x2 is 1 minus x1, that's 3. We know minus and a minus is a plus. So this becomes 5 plus 2. Don't let them trick you with that. And 1 minus 3 is minus 2. 5 plus 2 is 7 over minus 2. That's minus 7 on 2. Or some people prefer to put the 7 on minus 2. Doesn't matter. So everybody understand that? All you have to do, identify x, y, put it into the formula, and you have your answer. That's it. Everybody understands? If not, let me know. So yeah, no, maybe. Kind of confused? Let me know.
Yes, sir.
All right.
Yes.
Okay. Well, what I was saying before about x1, y1, x2, y2 being interchangeable, instead of using this coordinate as my x1 and y1, I could have used this one as my x1, y1. So coordinates is 1, 5. I could have said that x1 is 1, and then y1 is 5. And then I use the other coordinates as x2, y2. So in this case, x2 would have been equal to 3, and then y2 would have been equal to -2. So instead of having 5 minus -2 in this case, my y2 is now -2. So it's -2, subtract 5, and it's no longer 1 minus 3. It's now 3 minus 1. That's what I was saying, it's interchangeable. It doesn't matter, it's whatever you want to do. So -2 minus 5, that's -7, and 3 minus 1 is 2. Everybody understands that? Everybody understands that?
Yes.
Yes, miss.
Okay, well. Now we're going to do some questions. Okay, so say my first point, they want me to find the gradient, just like we were doing just now. Say my first point, A, let's name that A, is 4, 7. That's a 7. And I have point B. Point B is 10, 13. That's a 0. And 13. So could anybody tell me what's the first step? Step 1. Oh my God. 1. Anybody? Come on, people.
To determine what is x1 and y1 and x2 and y2.
So identify my x and y values. Okay. So x1, y1, x2, y2. If I wanted to choose A, point A, so that's 4, 7 as my x1 and y1. What's x1? Looking at this coordinates, which one is x?
4.
So that means y1 would be equal to 7. And then 10, 13. What's x2 and what's y2? Anybody?
X2 is 10, Y2 is 13.
10 and y2 is 13. Can anybody tell me what's the formula to find the gradient? Anybody?
Y2 minus Y1 over X2 minus X1.
Excellent. Good job. So in this case, this would be equal to my y2 is 13, my y1 is 7 over x2 is 10, and then x1 is 4. 13 minus 7 is 6, And 10 minus 4, also 6. 6 divided by 6, 1. So if they had asked me for the gradient, my answer would have been 1 in this case. Everybody understands how we got 1?
Yes, ma'am.
All right. Okay. Give me a second. Right. But like I said before, x1 and y1 are interchangeable. So I could have also said 10, 13. My x1 would have been 10. And then my y1 would have been 13 is equal to 13. And then 4, 7, x2 would have been 4. And then y2, 7. My next step is to use the gradient formula to find the gradient. So that's y2 minus y1 over x2 minus x1. In this case, instead of saying 13 minus 7, my y2 is now 7. 7. So it's now 7 minus 13 over, it's no longer 10 minus 4. X2 is now 4. So it's 4 minus 10 is equal to minus 6 over minus 6. A minus and a minus is a plus, and 6 divided by 6 is 1. So that's why my answer remains 1. Right? Next example. Say I have point P and Q. So P is 3 and 8, and then Q is 5 and 12. Okay, work this out and tell me what answer you get.
Miss, I got an answer.
Okay, what answer you get?
2.
2. So we have M is equal to 2. Anybody else got this?
Yes, miss.
Yes, miss.
Yes. Yes.
Yes,
Nice.
sir.
Yeah. Well, that is the answer. So just for revision purposes, when anybody watching this recording, let me do it. So P. I want P to be my X1 and my Y1. So that's 3, 8. X1 is 3. And Y1 is 8. 5 and 12. Okay, 5 and 12. X2 is equal to 5. And my Y2 is equal to 12. We have the formula up there, y2 minus y1 over x2 minus x1. So y2 is 12 minus y1, 8 over x2 is 5 minus x1, 3. 12 minus 8 is 4, and 5 minus 3 is 2, and that's how we ended up with 2. Everybody understands this, right?
Yes, miss.
Right. It's not difficult. Okay, last question. First person to answer again. So C is minus 4, minus 9, and then point B, I have oh my, minus 8 and minus 15. Right, so it's first was the answer. Tell me what you get.
Yes, I got an answer.
Okay, what's your answer?
3 on 2.
M is equal to 3 on 2. Anybody else got this? Yes, no?
Yes, ma'am.
Yeah, man.
I got that as well.
Nice, nice. Good job. That's your right answer. Right. So let's say my x1 is minus 4, my y1 was minus 9, x2 minus 8, and y2 minus 15. The formula m is equal to y2 minus y1 and x2 minus x1. So remember, it does not matter. In this case, I just want my y2 to be minus 15. So minus 15 and my y1 to be minus 9. Remember the minus, minus 9. Don't let that trick you. x2, I want my x2 to be minus 8, minus, minus 4. So continuing up here, minus 15, a minus and a minus becomes a plus, plus 9. Minus 8, minus and a minus, plus. So that's 8 plus 4. Minus 15 plus 9, that's minus 6. And minus 8 plus 4, that's minus 4. A minus and a minus, well, they will cancel out, becomes a positive. And 6 on 4 could be reduced to 3 on 2. And that's how we got that answer. So everybody good with that, right?
Yes, miss.
Yes, miss.
Right, good job. So, right. Right, those are the examples we just did. Okay, so you need to know as the gradient increases, the steepness of the line also increases. So look at this line, this red line. So let's say my gradient for this was 10. So m is equal to 10. My m is equal, the m is equal to 10. And as the gradient decreases, the steepness of the line also decreases. So this one, this yellow line, has the smallest slope. Why? Because it's less steep than the red line. So say my gradient for this one was m is equal to 2. So that's why we say as the gradient increases, so 10 is greater than 2. That's why this line is steeper than the yellow one. And as gradient decreases, 2 is less than 10. And that's why this line, this yellow line, is less steep than the red one or the blue one. So let's say the blue one was m is equal to 6. 2 is less than 6, and that's why it's less steep than the blue line. And 2 is less than 10, so that's why the yellow line is less steep than the red line. Everybody understands that? No? Yes? Maybe? Kind of?
Yes, miss.
Yes, miss.
Right. This is something you also need to know. Like my physics people too, this might come in handy at some point. Right. So a positive gradient. So m is a positive number. So say we had m is equal to 6. That's a positive gradient. Why? Because 6 is a positive number. Then the line would be going uphill. So there's my y-axis, there's my x-axis. And I had a line, it would be going like this. It would be going uphill. So uphill. You wouldn't, don't bother about this arrow. You wouldn't see an arrow, right? And negative gradients. If my gradient is negative, that means that it would be going downhill. So say instead of 6, now it's negative 6. Say this is my y-axis, my x-axis. Let me use a different color for the line. The line is green. if my gradient was negative, my line would no longer be going uphill, it would now be going downhill. Next one, horizontal line. Which one? Okay. A horizontal line has a gradient equal to 0. So again, y-axis, x-axis. If you see a horizontal line like this, then your gradient, aka m, is equal to 0. Everybody understands that one, because most people find the horizontal and vertical line kind of tricky. So you understand that? Every time you see a horizontal line, the gradient is always 0. Remember that. And last one, y-axis, x-axis. If my line is vertical, then the gradient is undefined. So m, undefined. So always remember that for horizontal and vertical lines. Everybody good with these, right?
Yes, miss.
All right. Equation of a straight line. So always remember the general equation of any straight line is always y is equal to mx plus c, where m is the gradient of the line, the same thing we were just finding for, and c is the y-intercept. So that's wherever the line cuts the y-axis. Let me show you what that would look like. Say this is my y-axis, and this is my x-axis. So this is x, and this is y. And I had a straight line. Say my gradient was, so I have a negative gradient. My line is going like this. Wherever the line, the red line, touches the white line. So in this case, it will be that point right there. This point right here. That will be my y-intercept. So it's wherever the line cuts the y-axis, that's known as my y-intercept. Everybody understands that?
Yes, miss.
All right. On any line, passing through the origin, it'll be formed y is equal to mx. Realize there's no y-intercept in this case. Here's y. So I have my y-axis like usual. So y, this is my x-axis. The origin has the coordinate 0, 0. Has the coordinate 0, 0. And that's this point right here. This point is called my origin. And any line that passes through this point, so say this is my line, it has a positive gradient. You could remember, see, y-intercept is where it cuts the y-axis. This line does not cut the y-axis. And that's why it does not have plus c here, right? No plus c. That's why the equation is only y is equal to mx. Everybody understands that? It does not cut the y-axis, and that's why there is no plus c, and it's just y is equal to mx. Understand that?
Yeah, miss.
All right. All right, so they might ask you to find the equation of a line. So they might give you 1 point on the gradient, or they might give you 2 points, like what we were doing just now. In this example, they gave you 1 point, so 1 coordinate, 2, 3, and my gradient is 5. There are two methods to find the equation of a line, is whichever one you prefer. So the first step is to identify x and y values. In this case, it's just x1 and y1. So 2 is x1, and in this case, y1 is 3. Step 2 is to identify or calculate the gradient. Identify the gradient, that's if it's given to you. See, sometimes you're given the gradient, and that's when you would just identify. So look at the question and see what the gradient is. Other times, you might have to calculate it. I'll show you that just now, right? So in this case, they gave you the gradients already. So all you have to do is identify it. M, also known as the gradient, is equal to 5. This told you that right here with gradient 5. The third and final step for this method is to use the formula y minus y1 is equal to m in brackets x minus x1 to find the equation of a line. How did they come about this equation? Let me show you. So m is equal to y, oh my gosh. M is equal to y2 minus y1 over x2 minus x1. Hold on. The meeting is going to end. So leave now and then rejoin.